How to reduce your environmental footprint and save our precious planet. Today, we rely on either fossil fuels, nuclear power, wind or the sun to generate energy, but they are all flawed. Fossil fuels emit tons of CO2. Nuclear power generates nuclear waste. Green energy solutions like windmills and solar power need maintenance and regular replacement of parts to remain in working order, and backup power solutions are required to handle interruptions to green power production. However, there is a sustainable solution. Infinite energy that can provide electricity, drinking water and heating for cities, and can even be used to remove CO2 from the atmosphere. The secret can be found in the Earth's core. The centre of the Earth is hotter than the surface of the Sun. This means there is infinite energy in the Earth's crust. Energy in the form of heat. There are two main challenges connected to accessing this energy. First, a solution is needed to collect heat quickly enough from the deeper layers of the Earth's crust. Secondly, we need to be able to transport this heat fast enough to the surface to make use of it. Solving these two issues will make geothermal energy production a viable option, and a cheaper alternative than current energy production solutions. Assuming these two challenges can be overcome, geothermal energy will be available anywhere in the world. This means that we can have access to an energy source that will never run out. The geothermal candle is a solution that addresses these issues. This system resolves the two challenges linked to accessing geothermal energy, bringing sufficient quantities of heat to the surface of the Earth. Now, what are the potential uses for geothermal energy? First of all, heat can be converted into electricity. The deeper in the Earth's crust the geothermal energy is collected, the higher the heat value and the more efficient the heat to electricity conversion will be. But it doesn't end there. We can do a lot more with the Earth's energy. Generating electricity uses about 15% of the heat energy. The cost of this electricity production is about 50% less than conventional systems. Of the remaining 85% of the heat energy, we could desalinate seawater and supply heating for cities and industrial facilities, thus replacing current traditional heating fuels, which account for more than 10% of the CO2 in the Earth's atmosphere. Aside from this, we can also use the heat and steam to run something called CO2 scrubbers. A CO2 scrubber takes CO2 out of the air by running air through a capture solution. These systems need electricity to create airflow, with ventilators to pass CO2-rich air through the capture solution. After the capture solution has collected sufficient CO2, it is heated to release CO2. After CO2 extraction, the capture solution can be used again to collect more CO2. What remains is pure bottled CO2 and clean air. With geothermal electricity production, steam is cooled using a chimney, similar to the cooling towers in nuclear power plants, creating natural airflow, thus replacing ventilators which consume electricity. Secondly, the heat used to extract CO2 is available as free geothermal heat, replacing current traditional fuels used for heating. Geothermal energy can replace CO2 produced when making electricity, while simultaneously collecting CO2 from the air. That's the principle. Now let's take a look at some of the facts and figures. By combining hydrogen and CO2, we can create a fuel that compares to diesel. Because this fuel is made up out of CO2 captured from the air, there is no additional environmental impact. The difference is that there is no pollution in the fuel, so it provides a clean burn without polluting exhaust fumes. No, really, by combining water, renewable energy and carbon dioxide. The fuel actually already exists. Bosch calls it e-fuel, Continental calls it synthetic fuels, and Audi is even setting up a facility to produce this fuel. Because of infrastructure compatibility with current distribution systems, we can achieve a CO2 and NOx neutral fuel for mobility. The principles of the geothermal candle. First, we need to build a pipe which penetrates into the Earth's crust. For every kilometre we dig, temperatures rise by 30 degrees centigrade. So at a depth of 6 kilometres, temperatures in the range of 200 degrees centigrade become available. Secondly, the geothermal candle uses the same principles used in heat pipes to transport the energy to the surface. A heat pipe is the fastest method for transporting energy. Heat pipes have been in use for more than 100 years and have a heat transfer capacity ranging from 5,000 up to 4 million watts per meter Kelvin. At the bottom, heat is collected from a heat source, while at the top, heat is extracted, thus creating the cold source of the heat pipe. Heat to electricity conversion efficiency is dependent on the quality of the heat. At 200 degrees centigrade, a turbine can reach up to 15% conversion efficiency. 6 megawatts of heat energy can be converted into around 1 megawatt of electrical power and 5 megawatts of heat energy. To transport 6 megawatts of heat energy, steam is converted into water at a rate of 1.5 cubic meters steam to 3 litres of water per second. However, The heat capturing potential of the pipe would diminish quite fast due to the fact that the pipe is narrow, so that the heat captured would cool down the surrounding crust quite fast, while the exterior layers with higher heat would supply heat too slowly to the pipe. To remedy this, vanes are created, extending outwards away from the pipe. These are filled with highly conductive materials, thus enhancing the energy collection potential of the geothermal candle. In the presence of a highly conductive layer, like charcoal or naturally occurring ores, this can eliminate the need for artificial vanes, as the average energy collection potential of the crust around the pipe is sufficiently higher. Accordingly, a single basic geothermal candle can provide 1 megawatt of electricity, enough to power around 750 to 1,000 homes, at 50% of the current cost of electricity production. This still leaves 5 megawatts of heat for city heating, water production, and CO2 scrubbing applications. And the best thing? Geothermal candles can be built anywhere in the world. This means that geothermal candles have the potential to 1. Produce CO2-free electricity. 2. Clean CO2 from the air. 3. Providing heating for cities and industrial facilities. And 4. Generate drinking water anywhere in the world. In addition to this, installation is so simple that this technology can easily be scaled into much larger installations.